Welcome to today's Explainer. We're jumping right into a really fascinating piece of curriculum today. We are looking at a mid-year TEKS math benchmark review designed for 8th graders, but it does something pretty unique. It actually blends standard geometric volume calculations with the concept of divine architecture. So let's explore exactly how this curriculum frames math. As you'll see, it's not just about crunching numbers. It treats these formulas as the foundational blueprints of the ultimate architect's design.
Okay, let's dive into this. The entire anchor for this material is 1 Corinthians 10:31. The source uses this specific scripture to set up a unique foundation. It teaches that mathematical precision is actually a form of stewardship. It turns a standard everyday volume equation into a much deeper lesson on honoring divine creation with care and exactness. The whole framework here suggests that solving a math problem isn't just about trying to pass a test. It's about carefully and responsibly stewarding the intellect you've been giving.
So here is our roadmap for this review of text standards 8.6a, 8.7a and b, and 8.8a through c. We'll start by looking at God's geometric design. Then we'll calculate some basic volumes, build a composite rocket shape, tackle a fun volume ranking challenge, and finally, we'll wrap up by looking at education through the lens of biblical morality. We've got a lot of ground to cover, so let's get to it.
Section 1, God's geometric design.
The curriculum actually asks students to step back and just look up at the night sky or look at a globe. It posits that the geometry of the heavens, the orbits of the planets, and the perfect roundness of the Earth are staggeringly precise. By teaching students to really grasp this physical geometry, the program aims to help them deeply appreciate divine design and, in turn, interact with the world and build things far more responsibly. Now, the core goal the curriculum sets out for the students is mastery. And in this context, mastery definitely doesn't mean just memorizing a formula for Friday's quiz and then completely forgetting it over the weekend. It means taking these volume formulas and applying them in totally new, unseen situations with absolute confidence. It's literally about building a mental toolkit and knowing exactly which tool to pull out, no matter what kind of geometric curveball comes your way. Section 2, Calculating the Basic Volumes. Grab your toolkits! All right, let's look at question 1, which deals with a cylinder. Step 1 is simple. Identify your key dimensions. Here, the radius is 6 feet and the height is 10 feet. Step 2, we plug those exact values into our cylinder volume formula, which, remember, is the area of the base times the height. Then in step 3, we actually calculate that final volume. By carefully squaring that 6 to get 36, multiplying it by our height of 10, and then by pi, the curriculum shows how careful, deliberate stewardship of the steps naturally leads you right to the correct answer. There's no rushing here, just precise execution. Now, what's really interesting about this slide is how the cone actually relates to the cylinder we just solved. For question 2, we have a cone where the radius is 4 centimeters and the height is 9 centimeters. The lesson points out this absolutely beautiful mathematical relationship. A cone's volume is exactly 1/3 of a cylinder that has the exact same base and height. So we square our 4 to get 16, multiply by the height of 9, multiply by pi, and then, this is the absolutely crucial part, we divide by 3. The logic of the formula does all the heavy lifting for us, as long as we guide the numbers accurately. Question 3 brings us to the sphere, and this ties perfectly back into that roundness of Earth metaphor we talked about earlier. But step 1 highlights a classic mathematical trap. The problem gives us a diameter of 12 centimeters. You have to convert that to a radius by cutting it in half, which gives us 6 centimeters. If you miss this step, your volume is going to be massively inflated. Step 2 plugs that 6 into the sphere volume formula, and in step 3, we calculate. We cube the 6, multiply by pi, and then multiply the whole thing by 4/3. Precision at step 1 absolutely guarantees success at step 3. Section 3, Building the Rocket Shape. A massive rocket might look incredibly complicated at first glance, but mathematically, it breaks down into totally manageable components. We have a cone on top with a radius of 3 and a height of 10, and it's attached perfectly to a cylinder with that exact same radius of 3, but a height of 15. The profound lesson the curriculum is imparting here is that incredibly big, complex problems are really just smaller, precise tasks put together. It's like a giant puzzle. You solve the cone, then you solve the cylinder, and then you just combine them. Let's see how this builds into the final result. Calculating the volume of that top cone and adding it to the carefully calculated volume of the cylinder beneath it yields the grand total volume of the rocket composite shape. This perfectly reinforces the idea that patience and step-by-step mathematical stewardship really do pay off. By faithfully applying the laws of geometry rather than just guessing, the correct total volume is achieved every single time. Section 4, the Volume Ranking Challenge. Let's see how these shapes relate. So the contenders for this conceptual challenge are a cylinder, a cone, and a sphere.
And to make it completely fair, they all have a radius of 5. For the cylinder and the cone, the height is exactly 10. The curriculum pauses here and asks the students to mentally predict the order of increasing volume before doing the math. So what do you think? Which one holds the least? Which one sits in the middle? And which one holds the most?
And this brilliantly illustrates the relationship. The cone is the smallest, the sphere is right in the middle, and the cylinder is the largest. But why? Well, remember, a cone is only 1/3 of the cylinder's volume. A sphere, with a radius of 5, perfectly bridges that gap. It fills more space than the tapering edges of the cone, but it lacks the full, straight edges of that massive cylinder.
Section 5, Education with Biblical Morality. Let's zoom out a bit.
The curriculum concludes by exploring the overarching philosophy of the Heroesmart Academy Godly Learner series. It strongly emphasizes that education without morality can ultimately lead to destructive choices. The program teaches its students that a sharp intellect absolutely must be paired with biblical morality, making the argument that simply being smart isn't enough to avoid hurting yourself or others. Referencing Romans 8:6-7, the material proposes that setting the mind on the Spirit brings life and peace, promising true peace of mind to those who blend their academic education with this spiritual foundation.
And the curriculum leaves its 8th graders with a final, provocative thought. How will you apply this godly stewardship and mathematical precision in your own life today? Whether you personally subscribe to this specific academy's philosophy or not, it is undeniably a fascinating look at how math and morality can be intertwined in an educational setting. Thanks so much for joining me on this explainer. Keep seeking wisdom and keep building responsibly.